A very good evening to all of you. And welcome to DRONERA, a webinar on drones, UAVs and related future careers, hosted by the Aeronautical Division of the SEDS chapter of Sri Lanka Technological Campus. My name is Aeronautical and I am the moderator for this event. This webinar is broadcasted simultaneously on Facebook Live and YouTube. At the end of insightful webinar, we will be hosting a Q&A session to answer all of your questions. So please make sure to drop all your questions and comment to the link in the chat box during the webinar. First, let me tell me about the SEDS. Students for the Exploration and Development of Space. SEDS is a non-profit organization that helps and empower young individuals to participate and make an impact in the space explorations. SEDS SLT is a registered chapter of SEDS Sri Lanka within Sri Lankan Technological Campus. For the welcome speech, I like to invite Darshana Kurupparachi, our project chair, to address you all. Darshana.
Recording in progress.
Thank you, Anuradha. Good evening, everyone, and welcome to today's webinar. It is with great pleasure that I welcome you to this one-day webinar, DRONERA, organized by the Aeronautical Division of SEDS SLTC. First of all, I bid a very welcome to our guest speaker, Mr. Taringa Suraj Chaturant. He is a drone specialist and currently Chief Executive Officer in SRQ Robotics. Also, he is the winner of the Best Researcher Award from National Science Agency of Australia for the implemented nano drone to the Assist in Search and Rescue 2020. I also welcome our beloved advisor, Dr. Nanda Gunawardena, all the lecturers and staff members who present here today. I extend my welcome to the Executive Committee of SEDS SLTC and all other senior members. Finally, I welcome all participants here today. Well, without taking much time, again, I would like to warmly welcome you all to today's session. Thank you.
Thank you, Darshan. Let me remind you once again that we will be hosting a live Q&A session to answer all of your questions. So please drop your questions and comments to link in the chat box. This webinar will be conducted in English as per the request for many registered participants. Without further ado, let me hand over the proceeding to our guest speaker to carry on the webinar. Mr. Taringa Suraj, over to you, sir.
All right, good evening, everyone, and thank you for inviting me for this great session. Hope everyone can see my screen and hear me well. And could please someone confirm that you can see my screen and hear me clearly?
Yes, sir.
Okay, great. Right, so today's topic will be UAV technology and the career opportunities in the same field. And if we consider about this particular field, the field of drones is a really vast field and it will take years to talk about this, but let's see how at what level that we can cover within the given time. Right. Hope most of the students here are undergraduates. Since most of the students here are undergraduates, I will be mainly focusing on the technical sides of the drones. First, let's see what does it mean by a drone, because usually we think all the flying mechanics or flying robots are known as drone, but usually the drone could be an underwater vehicle as shown in here, or it could be a ground robot used for several purposes, or it could be a flying robot like shown in here. So usually a drone could be a UGV, ROV, or a UAV. But the common term for these flying drones are UAVs that we use in day-to-day life. Let's see what are the UAV types that we can find in the today's world. There are many more UAV types which are in the research level, but these are the main UAV types that we could identify The first one is the single rotor helicopter, right? I think you all know what does it mean by single rotor helicopter. It has a main rotor here. We turn on the point. It has a main rotor here and a small tail rotor here. The main advantages of this single rotor helicopter are it does not need a runway, right? It can hover at one place and it can take off at one place. That's the main advantage. And then it can carry a higher payload. If you have seen movies or if you have seen YouTube videos, you might have seen that there are helicopters carrying heavy military equipment like tanks and heavy payloads. And it has a moderate flight time, not low, not high. Usually a helicopter have flight time about around 1.5 hours, 1 to 1.5 hours, but that depends on the battery or the fuel capacity of that particular helicopter. And the main disadvantage of this single rotor helicopter is it has a complex mechanical system which requires a maintenance regularly. Right. Then we have multi-rotor UAVs. Multi-rotor means not the single rotor, but this has multiple rotors. Usually we call these UAVs as quadcopters or drones. But why I use this term multi-rotors? Because there are several types of multi-rotors that we can identify, and quadcopters are one of them, just one of them. And this is the first one, bicopter. If you have ever watched the movie, the Avatar, you can remember that Blue species use this kind of a bicopter, which has only 2 rotors. This is a tricopter. Here it comes the quadcopter, the most common type, and the hexacopter and the octocopter. Right? This also does not need a runway to take off, and the payload carrying capacity depends on the number of thrusters that it has. Right? Let's say we use a quadcopter and we want to lift more weight. Then we can go for a hexacopter by adding 2 more motors, or for an octocopter by adding 4 more motors. That completely depends on our requirement. If you can search the web, you might see that there are octocopters which are capable of carrying heavy payloads, and usually these are used for carrying professional grade cameras in the film industry. Sometimes these are used in the delivery purposes as well. Then one of the main advantages of this multi-rotors is it has a higher stability and higher maneuverability, since it has several thrusters mounted on them. Right? But one of the main disadvantages is it has a very less flight time. Usually flight time stays between 10 to 20 minutes, but there are multi-rotor drones which has higher flight times, about 1 hour, but that depends on the technology that it uses. But in general, it has a flight time about 10 to 20 minutes. And then the next type, fixed wing UAVs, or usually known as airplanes. And the main advantage is this can carry a higher payload, because in a multi-rotor or a single rotor UAV, you need to generate an equal or more thrust than the payload that you carry, payload and the weight of the aircraft. But in this one, you use the Bernoulli theorem to generate lift, and you can use a lower power system or lower thrusters to carry a higher payload. That's the main advantage. Then this has a high flight time. Usually, if we optimize the system, we can achieve a flight time about 2 hours or more than 2 hours. And there are fixed wing UAVs which can fly up to 16 hours, right? Just by using a single battery and optimizing the system. The main disadvantages, one of the main disadvantages is this does require runway and cannot hover. It cannot hover at one place. Either you need to have a runway or you need to use a catapult. Like this, the one that I have shown here is a catapult getting ready to launch a fixed wing UAV. This is not a common one. It's called VTOL, or vertical takeoff and landing drones. This is a combination of a multi-rotor and a fixed wing UAV, right? Let's see this one. This probably is a fixed wing UAV, but it has 4 rotors. The main advantage of this VTOL, actually this is a hybrid version of a fixed UAV and a fixed wing UAV and a multi-rotor. The main advantage is you can take off at one place. You don't need to have a runway. And after taking off, you can transition from the multi-rotor UAV to the fixed wing UAV, right? So what we're trying to achieve by that transition is to have a higher flight time and to save the battery power. And because most of the times, as I explained, usually multi-rotors have less flying time because of the higher consumption of the battery. But in this case, in this scenario, the VTOL drone uses the higher current just to take off and just to land, right? After taking off, it will transit into a fixed wing UAV and performs as a usual fixed wing UAV, right? This one is, as I remember, called V22 Reaper. And this one is used by the US Air Force. It's a bicopter, it's a partially bicopter, and it's a VTOL as well, because after taking off, it can rotate its both rotors to the front direction and works as usual thrusters, and it will work as a fixed wing to a fixed wing aircraft. This is the next generation UAV power system, which is called the ion propulsion. And ion propulsion UAVs are currently in the research and development level, but this will be in the market very soon time. The main advantage of this ion propelled UAV is that you cannot see any kind of a moving mechanical part like propellers or rotors, right? Let me play this video of an ion propelled drone. But as you can see, there are no moving mechanical parts. It's just using an ionized flow to generate an airflow, and that eventually generates the thrust required to take off that particular drone. Right. So those are the basic types of UAVs that we can identify, and basic types of thrust systems or power systems which are available in UAVs. Next, let's see what are the key technologies. What are the key technologies? Not all of them, but some of the key technologies that are used in UAVs when designing and operating. Right. The first one is the airflow analysis, because if you are implementing a fixed wing drone, or you are trying to reduce the drag air resistance of a multi-rotor drone, first you need to do the airflow analysis using specialized software for that. Okay? So this is one of the engineering fields that you can follow if you are interested in the field of drones. Then mechanical design. In mechanical design, you have to work on several components. The main component is you need to do the stress analysis and strengthen up the places where you have higher stress to avoid breaking the whole system when hovering or when in the air, right? Then also you need to perform the air resistance analysis, as I mentioned. By performing this air resistance analysis, you can reduce the air resistance, and that will eventually increase the flying time. Then if you are in the field of chemical engineering, you can work on the composite materials, because usually the field of drones and the field of aviation is always trying to improve the strength of the materials that they use to build the aircraft and reduce the weight. Because one of the main problems that we have in the current drone and aviation industry is all the materials comes with a higher rate, and if we try to increase the strength, that will eventually increase the weight as well. If we can find better material which has a less weight and higher strength, then we can save the battery power, because the thrusters don't need to generate a higher thrust because of the less weight. Usually in drones, nowadays we are using carbon fiber, because that's one of the best materials which have less weight and higher strength, but that comes at a higher cost. But usually nowadays drone, we use carbon fiber tubes and carbon fiber plates to build the main structure of that particular system. Then the first three sections that I mentioned, the first three technologies are related to mechanical and chemical field of chemical engineering. And then we can come to the consider the field of software engineering and electronic engineering. The first one we can work on is the stabilization system. Stabilization means you need to make your drone hover at one place without crashing. That's the basic stabilization, but there are much more complex components inside that system. But basically, that's how we can define the term stabilization. Under that, we can work on control systems, right? The noise filtering, because usually these control systems use several electronic sensors which comes with noise. You need to work on noise filtering. And then disturbance compensation. That means when you're flying in an outdoor environment, there can be several disturbances like winds, and there can be several disturbances in the communication as well. Then communication. That's one of the major requirements in the field of drones, because since this is an unmanned system, we need to maintain a proper communication with the ground controller station, or either we need to pass control commands or navigation commands to that system. And if that system is a fully automated one, we need to automate the system. We need to monitor the system and find its location. And sometimes we need to get the video feed and monitor it from the ground control station. And in that case, communication is one of the really important components of this UAVs, right? Because you might have seen that some transmitters and some communication methods and devices use radio frequency, and there are novel drones which uses 3G and 4G frequencies, 3G and 4G technologies in order to control the drone and get the feedback. One of the main advantages of using 3G and 4G is you can control the drone and get the video feedback anywhere in the world. That's one of the main advantages, but eventually that will increase the communication delay, because usually if you use the radio frequency to communicate with the drone, that will take a few milliseconds. But usually if you use 3G and 4G, that will take you can only communicate with the drone a few times within a second. So that's one of the main problems in 3G and 4G communication. But still, some drones use that technology to communicate in between the ground control station and the drone. Final, the most important part, and that's the field where I'm specialized in, the drone autonomy. Right? Drone autonomy means there are several autonomy features. Right? First one, the most common one is the obstacle avoidance. If you have ever flown a DJI drone with a higher grade DJI drone, you might notice that it comes with obstacle avoiding features. Right? It uses an ultrasonic sensors to detect obstacle, and if there's an obstacle in front of the drone, it will automatically stop. Right? That's one of the automations or autonomy features that we can implement inside a drone. But there are several advanced features like autopilot systems where we can implement using several onboard computers. Right? When I mention the term autopilot systems, there are several subsystems in that autopilot system. The first one is the localization. Localization means identifying your exact position. Right? The drone needs to know where I am at. Otherwise, it won't be able to go to the given destination. Right? The first one, if someone asks us to go to a particular place, first we should know where we are. Right? After that, after getting the location that we need to go, we can plan our path. The drones do exactly the same way. Right? First, it should know its location. That's called the localization. Usually, if we are flying flying the drone in an outdoor environment, we can use the GPS. But if it's an indoor environment, right, or an underground environment, we cannot use GPS, and in that case, we need to rely on some other advanced technologies for localization. Right? Then path planning means plan your path in between your current position and the destination position. right? And if there's an obstacle or a restricted zone, right? Let's say we need to fly from Ragama to Chilao, right? Now we know that we are at Ragama, the destination is Chilao. But if we plan a straight path that will lies on the Karnataka International Airport, that we should avoid because it's a highly restricted area. In that case, we should plan our path to go around that airport. That's mainly called the path planning, because we need to avoid the obstacles and restricted areas and reach the destination. And the path planning depends on several other factors as well, because we need to calculate the remaining battery power, and eventually if that distance cannot be achieved with the remaining battery power, then we need to send a warning to the user, or we need to abort that mission, right? Then navigation means performing the following the path that we plan, right? So that's called the basic autonomy of a drone. And as I mentioned, there are much more features in the autonomy, right? Since I think that should be enough, right? That should be enough, and you might have a basic idea about the technologies which are associated with UAVs and what are the things that you can done and that you can follow by having an engineering background, right? So when the organizers of this session contact me, they asked me to specifically talk about the career opportunities in this particular field. So next we'll look at what are the career opportunities which are available, or what are the future career opportunities in this particular field. Right. So the first one is photographing and filmmaking, which you all are aware about by now, because that's one of the most common fields in the world. And even in Sri Lanka, we use drones equipped with cameras to take photographs and to take videographs in filmmaking, right? You might have seen that there's a separate mechanism called a gimbal attached to the camera, which counterbalances the movements of a drone, right? Otherwise, what would happen is, if you connect the camera directly to the drone, then the feedback that you get, or the video that is recorded by the video camera, will have some will record the movements of the drone, and it will not have a stabilized video feed, right? In order to counterbalance that unintended movement, or the movements generated by the external forces and external disturbances, we need to use a gimbal, which is a separate mechanical mechanism mounted in between the camera and the drone, right? Then usually we can have technicians repair services in order to repair crash drones and repair several defects in that drones that might get with the time. Then I will be mainly talking about the rest of the fields and job opportunities, which are really important to students with an engineering background. The first one is the surveying and mapping. Manufacturing means we are trying to or we implement, or we set up a manufacturing plant to manufacture either part of a drone or the entire drone, right? Then aerial inspections, engineering services. There are thousands of engineering services which are in most of the fields, in the field of software, electronics, electrical, telecommunication, and even in mechanical and chemical engineering. And then disaster management, finally research and developments, right? So let's see first what are the aerial inspection career opportunities that you can follow, right? Usually in aerial inspection, we have several applications in Sri Lanka as well as in the local foreign job market. The first one is the power line inspection. Power line inspection means you need to monitor the power lines with a thermal camera. This blue and red view can be obtained by using a thermal camera, right? Blue area denotes the areas with a lower temperature. The red area means areas with the higher temperature and with the brightness, right? If that area has a higher temperature, that area will eventually get a red color with a higher brightness, right? So what we are trying to achieve by this power line inspection is to identify the areas which has a higher temperature, because sometimes if we do not monitor that, that point might get melted down, right? That is called as a line breakage, and that one is a really critical one because you need to shut off the whole power system and send someone to that high altitude place and then repair that, right? So if we use a drone and a thermal camera, then we can identify that special area which is which has a higher temperature before it gets melted down, right? Again, this view can be obtained by using a thermal camera, right? And the career opportunities that are available in this area is either you can be a drone pilot or you can be the inspector, right? Sometimes both components are done by one person, but in some countries there's a separate drone operator and he flies the drone and record the video feed, and he passes that video feed to the inspector who has special skills in the inspection part. The next one, solar panel inspection, right? Solar panel inspection. Why is this drone imaging or aerial inspections using drones are important in solar panel inspection? Right? You might have seen solar farms with thousands or millions of solar panels, right? What if a single solar panel get defected, or if one solar panel stops working, right? You can notice that by monitoring the whole power output or the total power output from the monitoring station. But the problem is that it does not say where is the problem or what solar panel has the defect. If there are, let's say, that particular solar farm has 10,000 solar panels, then you need to go one by one and connect your meter and check whether it outputs the required power, right? That's a very or really time-consuming process. But if you use a drone which has thermal camera, you can cover the entire field within a few minutes, less than an hour. Then you can inspect that video field in order to identify the defected solar panel, right? So what usually happens in a defected solar panel, if that solar panel is working well, that absorbs the solar energy and it generates the electricity, right? But if that solar panel is not working, right, there's no way to go to the absorbed solar energy, right? So what will happen is that particular solar panel gets heated than the other solar panel, because other solar panels convert the absorbed energy to electricity, but if the solar panel is not working, it needs to do something with that absorbed solar energy. So eventually it will increase its body heat, right? If you observe this image, you can see that we can identify these solar panels have a higher temperature, which means that they are not working because they absorb solar energy, but they do not generate the required electricity, right? So within a few minutes, we can identify where the fault is or what solar panels are not working. Same as the before, you can be either drone pilot or you can be the inspector in this particular field. In Sri Lanka, Electricity Board tried to do this, but they had several problems. We had a discussion with them, and now they are using handheld thermal cameras in order to identify this. But if we can implement a way to monitor power lines using drones, it will be really useful in order to identify the melting points. Right. Next, the aerial inspections. Aerial inspections. The first one is you can inspect structural or buildings using a drone. You don't need to use thermal imaging. You can use a standard camera in order to monitor the structural or buildings which are hard to reach, right? Let's say you need to monitor a bottom side of a bridge, right? and it's a hard to reach place, you can send a drone and monitor what's going on there. Or if it's a building with a high altitude, you need to monitor the top level of a particular building, you can simply send a drone and inspect what's the problem or what causes that problem. Right. And then plant health monitoring. Plant health monitoring means the drones are widely used in agriculture operations. Right? In Sri Lanka, currently there are several companies which offers the agriculture service, the drone-based agriculture service, not the plant health monitoring, but crop dusting. Crop dusting means spraying the different kind of chemicals over your agricultural field. But we can monitor the health of the plants and identify which are not growing well and treat them by using a drone. Again, you can either be a pilot or you can either be an inspector. Right? And all these 4 applications, right? For all of these 4 applications, there are automated softwares where we can feed the video and it will automatically detect. Let's say it's a solar panel inspection. When we feed the video, it will automatically detect the solar panel or solar cell which has a defect, right? Because otherwise we need to keep watching or keep our eyes on the monitor for several minutes in order to identify that particular cell. But there are automated software for this one as well, and for the power line inspection. And for structural operation or structural inspection, there are, like, as I remember, there are no softwares available, because most of the softwares just map that structure, because structure might have several kinds of defects and several kinds of problems which requires to identified by a professional. And then for plant health monitoring, there are several softwares. We'll talk about that part later. Right. Then disaster management. I think you know how hard it's to find a lost hiker in Sri Lanka. Right? First, you get to know about that through TV and social media, that there's a group of students went to this area and now they are lost. Now the forces are trying to locate them, right? Then if they cannot locate them within a couple of days, then the Air Force comes in and they send a helicopter to find that lost hikers, which are not cost effective, which are associated with higher cost, because it might take, if we take a single flight of a helicopter, it will cost you a very high amount, right? But if we can use a drone to identify that lost hikers, that's really cost effective and time effective. This view is from a thermal camera as well, but with a different color palette, not the red and blue color palette, but with the black and white color palette, right? White objects means that they have a higher temperature than the environment. If we send a drone or that suspicious area, if we suspect that they might be in this area, then we can send the drone and we can have a broad view, since we are looking from the air, or we have an aerial view, right? That in that case we have a broader view, or we might we get the ability to see an area with a few hundred square kilometers. Since we have a thermal camera, we can easily identify the heat sources, in that case, which are associated with the body temperatures of these lost people. So it's a really cost-effective option in order to identify these lost people. And let's say if that's a flooded, if some area or one area gets flooded, and then the helicopter goes from the Air Force helicopter go there and try to identify trapped people. And in the night time, they have to use large flashlights and spend some time in the air, which will cost more to maintain that flight. But if you use a drone, the same scenario goes with that as well. We can easily identify the trapped people using the thermal imaging. In foreign countries, there are search and rescue services. They have these drones which are mounted with thermal cameras, and with that the drones will support the ground crew or the first responding crew in order to locate the trapped people or lost people and then reach them and to rescue them. And if they need some attention or first aid, they can use the drone to deliver that as well, first stage packages, right? So in a carrier point of view, either you can start a service something like this, which helps for disaster management, and or you can offer, or you can build devices, right, with automated solution. Let's say we build a drone which comes with a software or a mobile application, and we can use the mobile application to highlight the suspicious area, and then it will pass to the drone. Then the drone will automatically take off and search for the lost people in that particular area, right? You can implement that kind of a solution, and you can find clients for that particular solution, right? Or either you can if you are familiar with image processing and implementing neural networks, then there might be companies who are looking for these kind of engineers to implement neural networks or image processing stuff for these kind of applications, because there are several combined algorithms which run simultaneously in a combined or advanced human rescue drones. Then the next one, serving and method. What's the purpose of serving and method? I'm sure that all of you are aware of the uses of serving, right? If we need to measure a particular land with a higher accuracy, then we need to perform a survey, or we need to, if we need to find an exact distance between two geological locations, the higher accuracy, then we need to perform a survey. But let's think of a scenario where we need to find the distance between two geological locations, which roughly has a distance about few hundred kilometers, right? And we can assume that the ground is the plain one. It's a mountain area. That case, it might take several days to find the distance between those two geological locations with standard methods and equipment. But if we use a drone, to map that particular area, it might take a couple of hours to map the entire area. And after that, we can use a special kind of software to build the entire map. Because let's say we have an area about 10 square kilometers, right? We cannot capture the entire area without one pass by, or let's say we have a camera. We need to capture several images in order to cover the total area, and after that we can feed those images into a software, special kind of software, and that software will stitch all these images together and generate a single image. Using that single image, we can measure the distance between the required two geological locations. If we perform the standard methods, we can only find the distance between the given geological locations. If we need to measure some other distance or distance between some other location, then we need to perform that task again. But if we generate a map like this, we can measure the distance between any number of points just by sitting in front of a computer, right? So what's happening when we process these images, right? As I mentioned, let's say we have a area about 10 square kilometers. Then we command the drone to take off and capture images of this particular area. Then the drone will capture 1,000 or 2,000 images of that total area. Then we can feed those images into our software, and the software will process these images and generate single image like this. And with that, it tells us what's the accuracy of this particular image. Usually, the unit of that accuracy is given by the distance per pixel, distance per square pixel. Right? It could be 1 centimeter per square pixel. Then if we mark 2 points between this within this image, the software exactly tells us the distance with an accuracy of 1 centimeter. It doesn't matter whether it's a distance of 10 kilometers or 20 kilometers, we can still measure the distance with an accuracy of 1 centimeter. Right, let me show you an image or a mapping project which I did several years ago. It's a really large image. I'm not sure whether it will get opened with that with this presentation on. Let's give it a try. So it's basically a JPEG image, and the size is about 400 megabytes. Let's give it a couple of minutes. Right. So this is a map of University of Moratuwa, which I made several years ago, and this is a high resolution automosaic image. And as I remember, the drone captured about 600 images, and I had to stitch them together using a special kind of software. Let's see what will happen if we try to zoom this. And you can see the clarity of this image, right? This is not obtained from Google Maps, right? Because you know what will happen if we try to zoom the Google Maps up to this level. The accuracy of this map is 2 centimeters per square pixel. If I mark 2 points, let's say we use Photoshop and we import this image to Photoshop, and we mark 2 points, and we can get the distance in terms of pixels, and then we can multiply that number of pixels by that unit, the distance that it denotes by a square pixel. All right, let's go back to the presentation. Okay, so there are several services in Sri Lanka which offers this service, surveying and mapping services. If you need to make a map, a 3D map or 2D planar map for a particular area, you can contact them. Or either you can start one of these services in Sri Lanka. You probably need to buy several equipments and drones for that, and you need to purchase license for a special kind of software which is required to stitch all of these images together. But probably you can start one of these services in Sri Lanka, because this is one of the highly demanded areas in the world. Or if you get specialized in one of these areas, which means map stitching and map processing, then there are several vacancies out there in the world which you can apply for. Right. So we were talking about surveying and mapping. Again, this is one of the projects that we did a couple of years back, and this is to analyze land utilization in an agricultural field. Right. In agriculture, we can perform several analyses, and we can follow several techniques to analyze the health of that particular plant, which is called the NDVI analysis. But here we use the land utilization analysis method in order to find the utilized land of a paddy field. Right. So this is the overall image. This is the total image, and again, this is not a single image. We have to capture several images and stick together. After that, we feed this into a special kind of software which performs this land utilization analysis. As you can see, this red area means the underutilized, or the areas that are not utilized. Areas with a higher green color means that they are full of vegetation. Right? Since this area is not used, and the only area that they did the seed spreading, so seed spreading is this area. And if we consider this area, you can identify there are several red and yellow spots which can be considered as underutilized areas. So what we wanted to show in this project is that most of the paddy fields are underutilized. we can generate more yield, or we can increase the yield percentage by, according to our calculations, as I remember, that percentage stays around 28%. We can increase the yield by 28% using the same agricultural field or the same area, because we cannot see this, we cannot identify this if we try to observe this from the ground, right? We need to get airborne and do this analysis to clearly identify the underutilized area. And again, these red and yellow areas can be planted with more seeds or planted with more trees. Right. And this is a project that we did in collaboration with the Youth Services Council in Hambantota. We want to show them how they can improve the accuracy and automate this process using drones. Then the next one, we can offer several engineering services. There are thousands
Recording
of engineering
stopped.
services that we can offer, right? But I have mentioned some of these. First one is the fleet management software. If you are proficient in the field of software engineering, or if you are following software engineering degree, you can usually probably work on this one. What do you mean by fleet management? Fleet management means, let's say, let's consider a delivery drone. You need to deliver a package from the warehouse to a particular point. But if there are several customers, you need to use more drones in order to get their orders fulfilled. Right? But what they currently do is they use a single operator per single drone. Right? What if there are 100 orders? They cannot hire 100 drone operators. In that case, first thing that we need to do is we need to automate the process. Right? We just have to attach put the payload in, then upload the destination. Then the drone will automatically takes off, or plan its path and follow the planned path until it gets to its destinated location. Right? But there should be a single person who can monitor this process. Or if something goes wrong, or if something goes as if something happened which is not, or if something goes against the plan, he can abort that mission and he can take the manual control. Right? For that one, we need to implement a fleet management software where we can monitor several drones simultaneously.
Recording in progress.
Right? So that's basically what we call as a fleet management software. And there are several other features in fleet management software as well. Because first you need to establish communication systems for each and every drone. Then you need to rely on the network layers, and then you need to consider the packet loss, data loss as well. But basically, this is you can implement a GUI to monitor individual locations of each drones which are currently in the operation. Then custom electronics and hardware module implementation, which means let's say one customer or one client reaches us. If we are offering this kind of services, drone-based engineering services, one client might reach us and ask us to that they have a drone which can travel from one location to another location fully autonomously, and they want to transform this drone to a delivery drone. And now they want to implement a mechanism to drop packages. In that case, we can design a gripper or a package releasing mechanical mechanism, and offer our services. That's basically goes with the custom hardware module implementation. Or let's say they need a modular method, right? Modular device or modular method which can identify if the drone is crashing and automatically deploys a parachute. Right? Currently, this module is already in the market, but if if one client needs to customize that module or implement one of those modules from the scratch, then we can offer our service as well in this case. And there are thousands of electronic modules and hardware modules that you can implement based on particular applications. Then I explained this video feed analyzing software. If we are performing solar panel inspection or a power line monitoring, we can train a neural network, or we can implement an AI algorithm in order to identify the defected areas. Because sometimes they can have, if that's a desert area, they can have millions of solar panels which cannot be performed by a human. Then we need to automate that process using a software. Then high-level autonomy. What does it mean by the high-level autonomy? Usually, it takes some effort, and you need to learn about these things a lot, about sensor fusion, coding, and what's happening inside drone. If you try to implement an autopilot system from the ground level, or if you are trying to implement an autopilot algorithm inside a microcontroller, right? That's a very complicated process that will take some time to implement and then test and release your service. But there are flight controllers out there which the manufacturers or the developers have gave us access to that flight controller through a higher level interface, which means we can attach a flight computer. Before that, I need to clarify these terms: flight controller and the flight computer. Basically, flight controller means the critical processes of the drone, like the stabilization loop, runs inside the flight control unit, FCU. Right? The flight computer, you can run higher level missions, which are basically, let's say we need to travel from one location to another location, then we can perform the path planning and the mission analyzing inside the flight computer, because flight computer usually performs non-time critical processes which are not critical to the drone stability, right? That's why we have two separate units to do the automation part and the stabilization part. In higher level autonomy, the flight controller developers has provided us an interface to pass high level commands in a language that we can understand in order to perform automated missions. Let's say we can, in a flight computer, we can choose Python, the programming language, and ask the drone to take off and then reach to this altitude, right? Go up to until you reach 50 meters. And once you complete that, go to this particular GPS location. You can do that with a less number of codes. That's how you program a drone with a higher level language. But inside the flight controller, it performs much more complicated calculations in order to follow that commands, right? But since there are flight controllers which provides this kind of interfaces where we can use that interface to program that flight controller with higher level language, we don't need to implement these algorithms from the ground level. So we can offer these services as well. And if you are familiar with Raspberry Pis, NVIDIA Jetsons, probably you can use a Pixhawk flight controller, which they have given us a library called Mavlin. And you can connect these two computers through a USB cable and implement a simple Python script to automatically take off and go from one location to another, right? And if you want, you can mount several obstacle avoidance sensors on the drone and connect those to Raspberry Pi as well, and then implement an intelligent path planning algorithm if the drone detects an obstacle while performing the mission, right? Okay, so as I mentioned, there are thousands of engineering services that you can offer out there in the field. You can get specialized just in one field, because there are thousands of vacancies. If you search for the vacancies in this particular field on LinkedIn or in other vacancy offering sites, right, you can see what their requirements are, what they are asking for. right? The programming capabilities and experience in particular areas. You don't need to understand all of these in order to get hired by a drone company. Right? You just need to get specialized in single area because they expect deeper knowledge in a particular area. Then my most favorite one, research and developments. If you are planning your higher studies or even in companies, they usually perform research and development tasks in order to advance their technologies, right? Even the technologies out there in the world, right? You cannot think that we can implement that technology in a simple way. We also need to conduct R&D process in order to implement that technology within our company. In that case, we need to spend on these research and development purposes or research and development processes. These are some of the research and development areas or areas where we can conduct research and developments. The first one is the communication. Because usually we need to achieve a lower latency. In that case, the drone will act within a short time according to the commands that we given to the drone. And then higher range. Usually, if the range of the drone or the distance between the ground controller station and the drone gets higher, there might be a risk to fail that communication link. So we need to find a reliable method which we can achieve a higher communication range. And I explained this as well, 3G and 4G technologies. In order to achieve a higher range, we can use these 3G and 4G technologies, but there are several disadvantages. One of these are we cannot achieve a higher communication rate or higher packet rate in that case because there's a considerable transmission delay in the 3G and 4G technologies. But the main advantage is there's a higher coverage in the world and we can control our drone from anywhere in the world if the drone and our ground controller is within the areas that are covered by 3G and 4G signals. And there's a drone which is released recently, which uses this 4G technology to control the drone and transmit the video feedback into the ground station. The Parrot Anafi drone, which can be used for aerial inspection and aerial monitoring as well. And that drone is equipped with a thermal camera and a regular camera in order to perform these inspection tasks. Then redundancy. Redundancy means you need to compensate the errors generated by the electronics and mechanical systems. Usually sensors might get failed during the flight, right? The electronic sensors can get failed during the flight. In that case, the whole drone will get crashed. That will eventually lead to a crash, putting all of our investments at a risk. If we invest more on the hardware components and the power generating systems, we should focus on the control systems and the electronic systems as well, because if one sensor gets failed, all the total drone, the whole drone might get crashed. So that becomes a bigger problem if we don't focus on spending on the electronic systems. But in modern day flight controllers, they usually provide with 2 or more sensors for a particular sensor. Let's say if we have a pressure sensor, and if that fails, either it stops using that sensor, that flight control stops using that sensor, or there are a couple or more sensors on that same flight controller, and eventually that flight control system will stop using that faulty sensor and starts using the working sensors, right? So that's these kind of flight controls are available in the market, but comes at a higher price. Then power system fails. What will happen if a motor gets failed during mid-flight, right? In most cases, the drone will get crashed. But if you can remember from the types of multi-rotor drones, there I mentioned that there are hexacopters which has 6 motors and octocopters which has 8 motors. In that case, it doesn't matter if a single or 2 motors get failed, still the flight controller automatically detects that. The modern flight controller has the ability to detect that if 1 or 2 motors get stopped, and something happens during the flight, and it will automatically stops using that motor and use special kind of a control system to maintain the stability with the remaining motors. Especially in an octocopter, you can fail up to 4 motors, not 4 motors in the single side, but if you lose 4 motors, you can have a quadcopter configuration in that case. But usually it doesn't matter whether it's lose 1 or 2 motors, still the flight controller, the modern flight controller has the ability to detect that and maintain the stability. Right? I think I have one video where the drone maintains its stability. So here's a hexacopter, and during the flight, it loses one of its propellers. You can notice that. But the flight controller detects that and maintains the stability without having or causing any problem. Because you have enough points, enough thrusters, and enough thrust vectors in order to balance this mass. Right, that's it. And there are some ongoing researchers to maintain the balance of a quadcopter, even a single motor or 2 motors get failed. In that case, they follow a special kind of a movement, right? Because if you lose 2 motors in the diagonal direction, it will make the drone rotate at higher speeds, but that part is considered in the control system and try to land the drone without crashing it. And that is one of the ongoing researches in the world, because the quadcopter is usually the common drone platform used by the several industries. And then external disturbances. Let's see how much time we have left. External disturbance, there can be several external disturbances which are caused by the wind and signal disturbances. And I specifically mentioned this one because this is one of the trending topics in Sri Lanka, because previously the defense ministry purchased several drone jammers, but in foreign countries, in Sri Lanka, we use this to increase the security in our country, but in some other countries, these drone jammers are available in the market. An ordinary person can purchase this and use this to crash an industrial drone. If you have an enemy, or if you have a competitor to your company, they might use these drone jammers to take your drone down. Right? So currently, companies are focusing on conducting researches to get rid of these drone jammers, not to get rid of drone jammers, to detect if there's a drone jammer and eventually remove the effect caused by this. So last year I got the opportunity to work on one of these systems where they wanted to implement autopilot system and the control systems which does not get affected by drone jammers. But due to the NDA that we signed, I cannot expose the technology that I use, but for sure we can bypass drone jammers and reach to the designated location, even if that's a really powerful drone jammers, except that gives an EMF pulse or electromagnetic fields, right? Because if you blast an EMF, that will burn out all the electronic components, and that's a really dangerous scenario. But usually the drone jammers in the market use different kind of technologies which can be detected by advanced algorithm and bypass. And then endurance means the flying time and the flying distance. Usually in current drones, we use lithium polymer batteries because it has a higher discharge rate. But now the world is moving towards lithium ion batteries. because this has lithium-ion batteries have higher energy density and lower weight, and then some of the drones use fuel if that's an engine-powered system. There's another method called hybrid generators, which uses both battery power and fuel power in order to power up the drone. And if you can remember from the previous slides, I mentioned that the usual flight time of a multi-rotor drone stays between 10 to 20 minutes, but by using these hybrid generators, we can increase that flying time up to 2 hours. But this hybrid generator comes with higher weight that can be considered as a higher payload. And then this is the one of the trends in the world, using hydrogen powered cells, H2 cells, to power up the aircraft, and that's still the research level. And if you can remember from the previous slide, there's a special method called ion propulsion method, and that uses a battery. And it's really inefficient because still it's in the research and development level, but in the near future that they will find a way to increase the efficiency. Right, so basically those are the things that I plan to discuss. What are the career opportunities in these fields? And I'll go back to this slide. This field, I didn't discuss about the photography and the drone repair services and manufacturing services, and I think I covered all the other areas. And let's see some of other projects. I think I explained about a couple of the projects that I worked on. Let's see some of the other projects that I got the opportunity to work on. This is one of the projects that we did in Sri Lanka. We implemented an automated drone to spray seeds from the air, and we can select the land that we want to cover using a computer or a tab and load the seeds into the container. Then the drone will automatically take off and fly at a low altitude while spreading the seeds over the field. And so the autopilot system is fully implemented by myself, and we had a team to implement these mechanical parts as well. And this is one of the projects that I did while my time at Australia. I worked with the National Science Agency of Australia for a while, several years ago. And this is a engine-powered single-rotor helicopter. I had to implement a sensor fusion algorithm to localize this drone, right? You already know what does it mean by the localization. It's identify our current position. There you cannot use just the GPS for that part, because GPS comes with a higher error, itself comes with a higher error. Because if you use the Google Maps app, that it will usually use you a warning that your current location, the accuracy of your current location is accurate up to 40 meters. But we need a better accuracy in this system. We need accuracy into up to centimeter level in order to perform automated tasks. In that case, we have to combine several sensors together, including GPS sensor, in order to improve the accuracy. The weight of this helicopter is about 350 kilos. And after implementing that system, we tested it on a small engine-powered helicopter, which is shown here. Small clip. Yeah, I was monitoring the GUI to identify if something goes wrong. So I couldn't record the localization window of the computer. That's it. That's a really small clip. And this is one of the most important projects, which took about 3 years. Still, it's not finished. And as the moderator mentioned in the introduction, this project won the Best Research Award last year from the Australian government. This project was about implementing a nano drone, which is a palm-sized drone, right? The size of this drone is about 10 by 10 centimeters. The intended task of this drone is to assist in search and rescue operations in a GPS denied environment. What do you mean by GPS denied environment? if you go in an outdoor environment, you can use GPS to identify the location of that drone, which is called the localization. But if that's an underground area or inside a building, you cannot use GPS. You need to rely on some other advanced techniques in order to identify the position of this drone, right? And the intended application of these drones, since Australia having several disasters related to mines and caves, there should be a method to send robots, automated robots inside mines before sending the first responders, human first responders, because still there can be falling debris and gas leaks which will put their lives in danger. We need to implement a system which can assist them by identifying the locations of trapped people, gas leaks, and fires, possible fires. And there can be very narrow spaces and confined spaces which does not facilitate us to send larger robots or humans, right? So they wanted a system with a smaller size in order to go through these confined spaces, and that's why we implemented this nano drone. And here is one of the clips that we recorded while performing inside a testing arena. And this is the view of the drone. This is the view of the drone and how it performs. And this is the map generated of that particular environment, because in order to identify the location of a trapped people, you first need to build a map of that particular area. Since this is a squared hallway, this is the map. This is how it looks like when the drone generates a map. This is a special scenario called loop closing, where the drone automatically corrects the map after performing a one loop around that hallway. And this is one of the videos that we recorded while navigating in an actual environment, because they want to try this inside a building, since they want to launch this to assist in building collapses as well. This is the actual movement of the drone, and this is the generated map. Since there are no loop close, you can see that there are some errors, there are some overlapping areas of this map. But once the drone comes to a previously visited area, it automatically corrects this map. Right now, it comes to a previously visited area, it automatically corrects the map. Right. So that's one of the really interesting projects that I worked on. Okay, I think the given time has passed, and yes, hopefully and fortunately, I have finished all the planned topics. And if you need to know more about these technologies, you can contact me at this email. And once a month, I'm conducting Clubhouse sessions for free. If you're interested, you can follow this Clubhouse account. And sometimes I'm sharing tips related to robotics and drones in this Facebook group. Either you can follow this Facebook group, or either you can join with my Clubhouse account. Up to now, I think I conducted about 2 sessions. Okay, so that's it, and thank you. And if you have any questions, I'm happy to answer.
Thank you, sir, for the insightful session. Let's move on to the Q&A session. So the first question is, how do we make our drones and suitable mobile applications or a computer simulator?
Can you repeat that one?
How do we make our drone and suitable mobile applications or a computer simulator?
Okay, I think he's asking about how we can implement a drone inside a computer simulation, right? Because that's one of the methods that we follow when implementing a drone. Because if we straightly implement the drone without doing simulations, that will result crashes, and we have to spend more on purchasing the parts again. Usually there are several simulators out there where we can implement control systems, and you can even use MATLAB, and they have a library to simulate drones. But in industrial environments, usually we use ROS. ROS means Robot Operating System, which is a Linux-based OS, which you can install on top of Ubuntu. And there you have a special simulator called Gazebo. There you have there are several models out there implemented by several companies, which you can download for free and use the Gazebo in order to test those models. And most importantly, you can use C++ and Python in order to implement several autonomy levels. And eventually, I have no idea about the how we can use a mobile application inside that simulator. But if you can implement the mobile application and test that with your mobile phone, then you can implement some kind of an interface between that simulation software and the mobile phone using Wi-Fi. But I would recommend Robot Operating System as a better simulation software to implement drones. But if it's a fairly simple simulation, you can go with MATLAB.
Okay, sir. Thank you. So there is another question. Would you like to brief me about the drone technology for the space missions?
Sorry, I didn't get it. Can you repeat that?
Would you like to brief me about the drone technology for the space missions?
Right. So I have minimum knowledge about spacecrafts and space missions, but I'll just explain one thing. If you see the Mars copter, right, which is a single axle helicopter, in that case you need to consider several things, because we cannot use the sensors that we use for this kind of implementation, because in Mars they have a different kind of an environment. If we use the sensors that we use here, it might not perform as we expect. So first we need to find the details about the atmosphere and first select the components according to that. And as you know, it has a less density. It has less density, and you need to consider the speeds of the rotors and the angles of the rotor in order to generate the enough thrust, right? So yes, we can extend this drone-based applications in Mars. Especially, I think that the one I explained, the ion propulsion system or ion propelled drones, surely can be used for Mars missions or rover-based mission, because it uses an electric force and electrons in order to generate thrust, right? So that's one of the trending fields and upcoming fields in the world, is use of moving mechanical parts becoming disadvantaged with these technologies.
Looks like we answered all the questions. I believe you all had an enlightening webinar today. To deliver the vote of thanks, I would like to invite Imasha Amarasinghe to address the gathering. Imasha.
Thank you, Anuradha. Good evening, everyone. It is a great pleasure to deliver the vote of thanks on this memorable occasion. First of all, I'd like to give my hearty vote of thanks to our guest speaker, Mr. Tharindu Suraj Saturanga, for making an excellent presentation and making this webinar very meaningful. I'd also like to extend our thanks to our advisor, Mr. Nanda Gunawardana of SEDS SLTC, for his guidance, and all the lecturers and staff members of SLTC who are present here today. Further, a big thank you to our senior brothers of SEDS SLTC for guiding us to make this event a great success. And I specifically express my thanks to our organizers